Mars, also known as the red planet. Mars is the fourth planet from the Sun and the second smallest planet after Mercury. Mars has about 38% of Earth's gravitational field and has thin atmosphere. On November 26, 2011, the Curiosity rover was launched to space. On 6th of August 2012, the Curiosity rover has landed on Mars. The Curiosity rover has helped us by observing the surroundings and helping us determine whether life can be supported in Mars or not. My partner and I, representing the team Joe-Deez, came with our new model rover, the Jupiter-03. The objective of Jupiter-03 rover is to record the atmospheric surrounding in Mars, and also to capture sound travel in Mars, and also it can collect samples, soil, rock and mineral samples on the ground of Mars, and analyze every element up to its atomic level. The Jupiter-03 mask can also record and analyze surrounding radiation, including the spectrum of infrared and even any atomic radiation. It is said 4 billion years ago, Mars didn't look anything like how it looks right now. Mars actually looked more like Earth. It has thicker atmosphere, warmer surrounding, and even had oceans of water. So now, as we know, Earth's dying. Global warming, pollution, all these problems. This is where the Jupiter-03 rover has its own mission. The Jupiter-03's mission is to determine whether Earth can support life and to scan and analyze surrounding radiation to make sure the future, or also known as the Mars colonization project, will be successful or not. As you can see, the foundation of the Jupiter-03 rover is designed as such so it can move smoothly or without toppling on the uneven grounds of Mars. Lightweight, durable and extraordinarily strong material is needed to be used. So this foundation is built with space-age aluminium alloys. They were the best choice for me to build this body, the foundation body, and the wheels. Next, moving on to the head. The head consists of so many other parts. It holds many functions, such as it holds the main camera system, which is used to observe and record the surrounding. As you can see, the head is designed in a closed chamber way. So in this way, the main board, or also known as the brain of the robot, can be prevented from the exposure of Mars atmospheric radiation. The head also holds several other body parts, which would be the main camera systems, including the mass camera, chemistry cam or the cam, and even the navigation cams. And it also holds a 2000 volt solar panel as backup power, although it has MMRTG as its main fuel system. The head also holds another robotic hand-like device where it can be used to scrape the soil to analyze its rocks, solid and minerals to the atomic level. The whole design is built in a compact way so that the design would be more simple and would be easier to land on rover, which would make it more practical, of course. Next, we're moving to the scientific instruments in the Jupiter-03. First off, we have 6 wheels attached to the 6 geared DC motor wheels attached to the Jupiter-03 rover. Next, hollow tube phase-edge aluminium alloys were used for the foundation. The foundation is built in this way so that the rover can move on uneven ground, and even small steps. Next, moving to the power source. The power source is called a multi-mission radioisotope thermoelectric generator, or MMRTG. This MMRTG is the primary power source of our rover. However, a 2000 volt solar panel is also fitted to the rover. This is to reduce the risk of RTG. The main camera system contains a series of cameras, including the mast cam, where it provides multiple spectral true color imaging with mainly two cameras, and chemistry and camera complex, where two remote sensing instruments combined as one, which will be the laser induced breakdown spectroscopy and the remote micro imager telescope. Navigation cameras are also fit in this camera series. These allow us to get the actual surrounding, the actual position and location of our Mars rover on Mars. Moving on, the Jupiter 03 has its own robotic arm. This robotic arm is used to collect samples, to view samples, and also to experiment with those samples, where this particular robotic arm can collect sample and acquire microscopic images of rock and soil. Moving on to the light system, where a CDS sensor is used to record and measure the light intensity in Mars, and to give which allows us to have information about the day and night process, the day and night cycle in Mars. At the same time, it is also used to light up the main front lights for better view at night or the dark time. Going on, this particular Mars rover can be controlled remotely from Earth. This allows us to control the rover's main movement, such as the forward, backward, right, left, and also to collect samples and run the tests. We have included IR sensors on each corner of the rover, basically 4 corners of the rover, so we can come up with our own anti-hazard system, where the main hazard would be falling hazard. These IR sensors enables our rover to drive itself. With the help of navigation cam, it can drive itself to a certain location or certain point on Mars, and also avoid falling from high distance. This infrared sensor system also includes the TIRS, or also known as the thermal infrared sensor, from the Mars Environmental Dynamics Analyzer, MEDA. Environmental sensors helps us to measure net thermal infrared radiation and reflected solar radiation at the surface, as well as the atmospheric and surface skin temperatures, using 5 different channels. In combination with MEDA sensors, TIRS will allow the quantification of surface energy budget and determination of key geophysical properties of the terrain, such as albedo and thermal emission. In a nutshell, I would say Jupiter 03 is a wonderful robot, a wonderful rover. Why I say this is because of this design. The main idea, or the main reason we came up with this idea, is to maximize its compactness, to make sure all these parts are compact enough to give it a simpler outer look, which will make it easier to launch it in space and land it on Mars. And if you can see, this particular design is pretty more practical than all other design. Our team, me, Shiva, and my friend Ruben, have came up with several other ideas. We came up with a drone idea, but when we check about the challenges a drone might face in Mars, a drone is very fragile, and Mars atmosphere is very thin, and also the gravitational acceleration, or the gravitational field, is 30% less than Earth. So it's highly incapable to have a continuous flight in Mars. Even NASA cannot have continuous flight in Mars. Maximum up to 100 seconds approximately. So this makes it highly impractical. Because of our rover is practical, our Mars rover Jupiter 03 is able to be launched and land and be operational in Mars very soon. The test can be run. Upcoming tests can be run, and I'm very confident that this is the most practical design. Although it came with upgraded versions than the previous Curiosity rover, which is the compactness. That is the main thing. And if you're talking about sustainability, our rover comes with 2000 volt solar panel. It might be big, it might be heavy, but as I said, the gravitational field strength in Mars is just 38% of Earth's. So the weight would not really matter. So as a secondary backup power source, this could be very reliable and sustainable on Mars, as it also reduces the pollution and radiation and contamination in Mars. So I would say, if you're looking for for Mars rover to be sent to Mars to determine whether life can be supported there in a very near time, in a very near future, I present to you Jupiter 3.